Hey folks, and welcome back. In our last video, we talked about what chemical reactions are, and today we're going to actually talk about how to balance chemical reactions. So let's go ahead and jump right into it. Remember, first of all, that when we have a chemical reaction taking place, that there's a certain structure for the accompanying chemical equation that we're going to write. So for our equations, we have the reactants, which is what we start off the reaction with, and then we have the products. And that is what the reaction turns into. So that's what is produced after the chemical reaction. And separating the reactants and the products is the yield sign. And the yield sign is basically showing us what are the reactants and then what are the products. Remember, it's kind of replacing the equal sign in our chemical reactions. And the reason why we do that is because the reactants are not the same thing as the products. Now, what is going to always be the same is that we are always going to have the same amount of elements on both sides of a chemical reaction. Why is that? That's because of the law of conservation of mass. Whenever you go through a chemical reaction, the amount of each kind of atom does not change. All of the atoms that you started with at the beginning of the reaction, you need to have all of those same atoms at the end of the reaction. Now, those atoms have been rearranged. They will be changed in, the bonds will be broken. You'll get new substances being formed, but the number of atoms will be the same. So for example, if we take a look here at this diagram, the oxygens are the red and the hydrogens are the white. So here we have a total of two oxygens in the reactants, and we have two oxygens in the products, right? Those are all of the oxygens there. Again, we have the same number on each side. If we take a look at the hydrogens, right? We have 1, 2, 3, 4 in the reactants, and then we have 1, 2, 3, 4 in the products, okay? So the law of conservation of mass states that when we go through a chemical reaction, the amount of each kind of atom, the number of total atoms of each kind is going to stay the same. However many you have on the reactant side, you need to have the same number on the product side. So how do we go about actually balancing a chemical equation? Because what's going to happen is that you're going to be given equations that are generally unbalanced to start with. They don't have the same number of atoms on both sides of the equation. Well, in order to do that, you are allowed to change only the coefficients, okay? You are allowed to change the coefficients, and you are only allowed to change the coefficients. Remember that the coefficients are the numbers that go in front of the element or compounds in the chemical equation, all right? So what would have happened with this one is that you would have been given CH4 plus O2 yields CO2 plus H2O. And that would not give you enough of the oxygens on both sides of the equation. And so what you have to do is you have to go about changing the coefficients in order to get the correct number of total molecules. You are not allowed to change anything else in a chemical equation. All right. So when you get practice questions, you're not allowed to change the subscripts. You're not allowed to change the atoms. You're not allowed to add new compounds or new elements. You're only allowed to change the number of coefficients. And what we're saying when we change the number of coefficients is that we're changing the numbers of these molecules. Okay. We're changing how many oxygen molecules, how many O2 molecules they are, or how many, in this case, H2O molecules there are, all right? Now, we're about to do some practice examples, and I highly recommend that as we're going through this, you use your stylus and you follow the same procedures that I'm doing. For some of you, this is going to be really intuitive. You're going to be like, oh, it's just basic math, multiplying, right? I'm just going to be adding in some things. It's going to be simple. For others of you, you may need to spend a little bit more time with this and take your time, okay? These are not things that you're really going to be able to easily Google, okay? So you're going to need to be able to do this process that I'm about to show you all, okay? So let's take a look at our first example. Here's our example equation. Li plus S gives us Li2S. Now, you're always going to be given the equations just like this with just the text. Here's what I recommend. I recommend that you rewrite underneath the text a little diagram or a representation of these. Now, if you want to use colored dots, you can do that. But what I like to do is I like to just come up under the text and I'm going to write LI. That represents that one that's here, right? Remember, we're assuming that there's a one here. An S. And then this is Li2S. Now, this is where we need to remember our rules for counting the numbers of elements. This 2, we need to know, applies to the Li. Okay, it does not apply to the S. This is saying that there are 2 lithiums. So what I would do is I would write Li, LIS. And the reason why I would do that is that it's going to help you to remember that there are 2 lithiums. It can be confusing if you just write Li2S, because again, this is not something that we're super confident, super comfortable with yet. Okay, so what we have here is on, and the final thing that I would do is I would draw a line where your yields sign is. And I would label that this is the reactants and these are the products. And the reason why you need to do that is because you need to have the same number of reactants as you have products. And so if you don't split it apart, you may get confused and you may not end up with the correct numbers. Okay, so that's our initial setup. The next thing we want to do is we want to figure out how many more do we need to add? Well, I've got 1 lithium on the reactant side, but I have 2 lithiums on the product side. So what I'm going to do is I'm going to come in and I'm going to write in another lithium. Okay. Now I can do that because this is what I started with. I started off with 1 lithium. So I'm allowed to add only 1. In some of our future examples, we're not going to only be able to add 1 at a time. And that's because, again, we can't change anything about the equation other than the coefficients. So we take a look now. We have 2 lithium on the reactant side. We have 2 lithiums on the product side. So that's all good. We have 1 sulfur on the reactant side, and we have 1 sulfur on the product side. So that is good. So this is now a balanced chemical reaction. The final step here is to go in and write the coefficients. We want to write those in. And we do that by looking at how many of each of these molecules we have. So we have 2 lithiums, so we're going to write a 2 here. Okay, that's the coefficient. For the S, right, we have 1 of them, so we're going to write 1. And for the Li2S, again, we have 1 of them, so we're going to write a 1 there. So your balanced chemical reaction is 2, 1, 1. Now, we don't technically have to write the 1s, but I'm going to make you write the 1s for now because I want you to show me that you know that this is a balanced chemical reaction. If you just leave those blank, I don't know that you know that you're done. So by writing in the 1s, you are showing me that you know that this is the correct final balanced equation. Okay? So again, we don't technically have to write them. However, you need to write them for me so that I know that you understand what's going on. Okay? All right, let's go to our next example. Let's take a look at Fe2S3 yields Fe plus S. So again, let's start off, let's find our arrow. Okay, these are the reactants. And in this case, we only have 1 reactant, which is fine. And then here are our products. So Fe2S3, this is saying that we have 2 irons. So I'm going to write in Fe, Fe, and then we have S3, that's 3 S's, S, S, and S. So again, I like writing those out so I can visually see how many of each atom I have. Okay, over here it's just Fe, and then we have S. All right, so let's take a look. We've got 2 irons on the reactant side, that's the Fe. I only have 1 on the right, so I need to add a second one. I have 3 sulfurs on the reactant side. I only have 1 on the right, so I need to add on 2 more. Okay, so now I have 2 irons on the reactant side, 2 irons on the product side, and I have three sulfurs on the reactant side and 3 sulfurs on the product side. So this is now a balanced chemical equation. Final step, we need to go in and write in our coefficients. We just have one Fe2S3. I have 2 Fe's and I have 3 sulfurs. So this is now a full balanced chemical reaction. Now, for those of you that are more math people, let's take a look at how we solve this mathematically, if we're not just doing it visually. We have Fe2. Remember that we assume that there are subscripts of 1 right here. Well, 1 times 2 is 2. 2 times 1 is 2. So we can just add in the correct coefficients here to make that balanced. 1 times 3 gives us 3 sulfurs. 3 times 1 gives us 3 sulfurs, right? But again, you don't have to do it that way. I think this visual method is pretty simple, straightforward, and easy to do. All right? All right, let's head on to our next example. Okay, with this example, right, we've got to pay attention a little bit to our subscripts, all right? Again, let's start off by splitting things apart. Reactants and products. All right, NH4I, the 4 is related to the H's. So this is going to be N1, 2, 3, 4, and then we've got the I, and then we have Cl2, so that is 2 chlorines. All right, and then NH4Cl, so this time it's the 4 H's are here, and then Cl, and then we have I2. So we've got 2 I's. Okay, now hopefully we're a couple into this. We should be able to get to the point where we start to recognize what is balanced already and what isn't balanced already, and we need to kind of come back and take a look at. So let's see. We have I2 on the right, so we've got 2 I's on the product side, but we only have 1 I on the left side. So we need to balance our number of iodines, okay? But I cannot add just I, because I is just an iodine by itself is not the same as what we have already. We are only allowed to add more of the entire molecules that we already have. When we add coefficients again, we're saying we're adding more of what we already have. So I have to add a whole extra NH4I molecule. Okay? You are only allowed to add more of what you already have. So now I have 2 iodines on both sides, but I now have 2 nitrogens on the reactant side, and I have 8 hydrogens, okay? So in order to balance this, I need to add on some more nitrogens and hydrogens on the product side. Well, it just so happens that we have this molecule here, NHHHHCl, right? NH4Cl. So if I add another one of these, now I have 2 nitrogens on both sides. I have 4 hydrogens on both sides. And this also takes care of, oops, went forward. That's not what we wanted to do. It also took care of our problem with the chlorines, right? We had 2 chlorines on the reactant side. I had only 1, but now I have 2 chlorines on both sides. So this is now a balanced chemical equation, right? But again, the key here is that I'm only allowed to add more of the molecules that I already have. So what does this look like? Well, we have 2 of the NH4I's, so we'll put a 2 there. I have 1 Cl2. I have 2 of my NH4Cls, and I have 1 iodine. All right? So this is our balanced chemical reaction here, or balanced chemical equation here. Again, if you're thinking about this mathematically, right, 2 times 4 gives us 8. 2 times 4 gives us 8 for the hydrogens. 2 times 1 gives us 2 for the nitrogens. 2 times 1 gives us 2 for the nitrogens. 1 by 2 gives us 2 chlorines. 2 times, remember there's a 1 here, gives us 2 chlorines. And then 2 times 1 over here for the iodine gives us 2. 1 times 2 gives us 2. So a couple different ways that you can approach these problems. All right, let's take a look at our final example here. I have PbI2 plus Al yields AlI3 plus Pb. So again, let's start off. Let's make sure we identify the reactants and the products, because we have to make sure that we're balancing between those two. So these are the reactants. These are the products. Okay, so let's start off. We got PbII. We have aluminum. We have AlII, and then we have Pb. So when we take a look at this one, the only two that are different are the iodines, right? Okay, but we have a slight problem. We have an odd number and an even number. And this is where things can be a little tricky, all right? I can't just add, again, just like we did last time, I can't just add an iodine here, right? That's not possible. We don't have just I in our equation. We have lead iodide, right? PbI2. So I have to add on a whole nother iodine with the lead, right? PbI2, I have to add on another one. But now it's 4. That's 4 iodines instead of 6, or sorry, instead of 3. Here's where using a little bit of our math skills is helpful. What is the least common multiple of 2 and 3? Well, it's 6, right? So what we want to get is we want to get to 6 iodines on both sides. You can also just guess and check this if you want, but if you guess and check, you may end up with numbers that are too big. So the least common multiple between 2 and 3 is 6. So I need to get to 6 iodines on both sides. So let me add on one more PbII and another aluminum III. So now that I've done that, I now have 6 iodines on both sides of the equation, which means that they are balanced. But by doing this, I've added on some extra leads, right? I've added on some extra leads and I've added on some extra aluminums. So I need to make sure that my leads are balanced. So I have 3 on the reactant side, which means I need 3 on the product side. And I have 2 on the product side for the aluminums, which means I need 2 on the reactant side. So now if we count it up, I've got 3 leads, 2 aluminums, 6 iodines, 6 iodines. So we'll go back in, add in our coefficients. So this is going to be 3, 2, 2, 3. All right. So what you need to do now is at the end of the notes, you need to do your summary, and then there is a link to the PHET website, the PHET website. So and it is going to take you to the PHET for balancing chemical equations. I'll show you what that looks like right here. All right, so you'll follow that link to here. You're going to click on the play button. So you're going to click on that. It's going to load the simulation. And what you want to do is just go through the introduction. What you're going to see is that you basically just, you've got 3 different things here. You want to balance these equations. So when you click on these arrows, see how it adds on things. Notice here we've got 2 nitrogens, so we need to add an extra one here. Now I've got 2 nitrogens and 3 hydrogens on each. So that's a total of 6. So I need to add those on here. And then once you've got it, it'll give you a little smiley face. If you want to use some tools to help, you can. Once you've done that, you want to click on the game. And I want you to play levels 1 and 2. Once you finish each level, take a screenshot and add it into the document. And if you want, you can do level 3 for a bonus. Levels 1 and 2 are what are required. Level 3 is a bonus. So you want to, again, add in a screenshot showing that you have completed each of levels 1 and 2. And then you will submit that through Kami and you're good to go. All right. Thanks for watching. If you have questions, please let me know.